Okay, so welcome to today's lesson. We are concluding on chemical equations, the types of chemical equations, where we established last time that there are basically four types of chemical equations, although there could be more, but these are the key ones, at least for those who are beginning chemistry for this level. So now, the first example or type of chemical equations is synthesis equations. Then the second one is decomposition. Third one is a simple or single displacement. Then the other one, or the last but not the least, is a double displacement. So in the previous video we explained what synthesis equations are, and we also gave examples of synthesis equations. So if you missed it, you can go over and watch the video on synthesis equations. Then now today we're moving on to the second type of equations, which is decomposition equations. So in the previous video, again, we established that decomposition equations is where you have a bigger compound, or rather a larger compound, that is breaking down to form simple compounds or simple elements. So you have, for example, AB that is breaking down to form A and B. So these could be compounds or simple elements depending on what type of a compound you are looking at. So whenever you see a larger compound that is breaking down and forming such compounds or elements as products, just know that the type of equation that you are looking at is a decomposition equation. So I'm going to give a few examples, then I would like to see what you come up in the comment section. So now the first example that we are going to look at is this one. Okay, so this compound is known as calcium carbonate. So calcium carbonate can break down to simpler compounds of calcium oxide, and always remember that the plus that is shown on the direction where the arrow is pointing is read as and. So calcium oxide and carbon dioxide. So these are the products that are formed from a larger compound. So this is what we meant. So another example that we can come up here is so this is B, where you can have this element. I'm sure on the periodic table you should know that this is zinc carbonate. Can also break down to simpler compounds, which is zinc oxide and carbon dioxide. Another example, just to make sure that you do get the concept here. So the last example that I'll be giving here is where you have a compound like magnesium carbonate, where the products will be magnesium oxide and carbon dioxide. So just for good measure, I would like to add another example so that someone may fully understand what we are trying to talk about here. So you have ammonia. So this compound is known as ammonia. So when ammonia breaks down, you are going to have ammonia and like that. So ammonia is formed, can break down and form these two elements. So these are simple elements that are coming from one larger compound. So these examples, I hope they are helpful. So now we are moving on to another type of chemical equation, where we are going to look at single displacement. So single displacement equations, these are simple equations that where an independent element, usually metals, react with a particular compound which is made up of a lesser reactive element. Then that single element has the ability to displace another. So for example, if you have an equation like this one, then A reacts with BC to form AC, then B is displaced. So A takes the place of B. Since B is lesser reactive than A, it is displaced and goes and stands independent like that. So now in the other examples that we are going to have here, typically here usually you have, for example, metal reacting with an acid to form a salt, and usually hydrogen gas. So some of the examples that we are going to establish here is, for example, one, you have magnesium reacting with an acid which is hydrochloric acid. Magnesium reacting with hydrochloric acid. Since magnesium is more reactive than hydrogen, so it will take the place of hydrogen. So what we are going to have is magnesium chloride and hydrogen gas as a byproduct. Another example that you might have is sodium reacting with a particular compound, sulfuric acid in this case. This sulfuric acid reacts with sodium. So sodium, since it is more reactive than hydrogen, so sodium will take the place of hydrogen. So you are going to have this compound here like that. Yes. Yes. Then the last example that we are going to look at is if you have calcium reacting with phosphoric acid, your product here will be calcium phosphate. Okay, calcium phosphate